So welcome everyone. This is Deb Sparks from the Centre of Excellence for Prescribed Burning, and we're really overjoyed to have Neil Burrows with us here today to present his webinar. He did present it at the AFAC 18 conference. He was a keynote speaker. Neil's recently retired as a senior principal research scientist with the Department of Biodiversity, Conservation and Attractions in WA, so we're quite privileged to have him here today to represent his keynote speech. Thank you, Neil.
My pleasure, and thanks for the opportunity. So, Deb, to get started here, should I hit the Start Slides button?
No, you should have the
It's all there. No, it's all come up, right. Yep, no, I've got it. So I'll get straight into it, eh? Yep, okay, yeah, as I said, thanks for the opportunity. I really appreciate it. And as you said, I'm going to present this webinar, which is exactly what I presented at the keynote in Perth in September. And at that conference, I said that given I was about to retire, I'm actually technically not retired yet. I'm on long service leave, but I do retire at the end of that in early January. But given that I was about to retire, it might have been appropriate for me to have reflect on how far we've come in bushfire science and bushfire management over the 42 years or so that I've been in the game. In fact, one of the organisers of the conference suggested that that's what I might do, but I decided not to do that. But instead, I took the opportunity to explore an issue that's dear to my heart, and I believe that is really important, and that is to explore the conflicting evidence, and I can't think of any other way of putting it, over the efficacy of prescribed burning as a bushfire mitigation tool. But at first, I will make some general observations from my 42 years of experience. So in the last 40-odd years, there's probably been upwards of, I don't know, I haven't counted them, but 800 or so bushfire-related scientific papers published. So we certainly know a lot more than what we did when I started. We have much better equipment today. We've got incredible technology that we could not have imagined 40 or 42 years ago. Our firefighters are better trained, they're better equipped, and we have more of them. But despite these advances, the area burnt by bushfire has increased in most jurisdictions and at best has remained unchanged in others. Certainly the climate has changed and Australia's population has increased by 11 million people. These factors are largely beyond the control of fire and land management agencies. And in the last 40 years or so, the area burnt by prescribed fire, which can be controlled by fire and land management agencies to some extent, has decreased in most jurisdictions and at best has remained unchanged in others. So making evidence-based decisions about the efficacy of prescribed burning is a pivotal hazard mitigation tool is extremely important because it affects community and firefighter safety, the health of our natural environment. So for these reasons, I doubt there's a more important land management practice. And for these reasons, I'm concerned that there is conflicting evidence about the efficacy of prescribed burning. Of course, I come from a Western Australian perspective, but I believe my observations, which I'll run through in a tick, are relevant to all fire-prone environments. Not only is prescribed burning important, but it's perhaps the oldest land management practice in the world, predating European settlement of Australia by thousands of years. The use of fire by the first Australians was widespread, purposeful and skillful, as far as we know. And I've been privileged enough to have worked closely with traditional people in the desert country of Australia to know that. Fire was essential for their physical and spiritual well-being. And while we have a pretty good understanding of how and why Aboriginal people burnt and still burn the northern and central Australian grasslands, our understanding of the intricacies of prehistorical fire regimes of southern Australia is less clear. It was relatively recently, I guess, with the arrival of Europeans that there was, perhaps after thousands of years, a significant reduction and in many places a cessation of prescribed burning. Aboriginal people were displaced from their land and their ancient fire practices were outlawed. Within a relatively short time, fire regimes flipped. For example, in the WA desert or central deserts of Australia, the fire regime changed within about 15 years or so of the cessation of traditional burning. Today, most of the desert is gripped by an uncontrolled, damaging bushfire cycle. In the early 1900s, following the establishment of the various state forest departments, the fire policy was largely one of prevention and suppression. And prevention amounted to taking measures, including punitive measures, to eliminate the causes of bushfires, but it also included some controlled burning, certainly in Western Australia, and I think it's the case across Southern Australia, or the forests of Southern Australia. The foresters of the day were mixed in their views about fire. For example, in 1916, D.E. Hutchins, a European-trained forester and colonial conservator of forests here in Western Australia, wrote that, and I quote, "It is repeated fires at short intervals that destroys the forest." Others blamed frequent burning by Aborigines for the low nutrient status in forest soils. However, others were of the view that controlled burning was the key to the bushfire prevention and suppression policy. The 1927 WA Foresters Manual noted that if the forest fuels were no older than 3 years, then there would be no damaging bushfires. The manual went on to suggest that burning the entire 2.5 million hectares or so on a 3-year rotation would essentially eliminate damaging bushfires. Of course, from a fire behaviour viewpoint, the manual is right. If the forest were burnt every 3 to 4 years, there would be no damaging bushfires. But of course, it was then and is today impractical on many levels. So for pragmatic and other reasons, controlled burning in the early days was largely restricted to what they called, certainly in the southwest here, 5 chainers, which were 100-metre strips or green belts, they're also called, around towns, mill settlements, major transport corridors and regrowth forests. And on reading some of the early accounts of fighting forest fires in southwest WA, somewhat bemused by how the fires were so readily contained by simple means. The usual procedure for fighting a forest fire is described by Forester George Brockway in a paper he published in 1932, from which I quote. George said, "Unless a fire is particularly fierce, it can usually be suppressed by direct beating with bushes. For this purpose, a healthy red gum branch is preferable." And he then goes on to describe in great detail the best fire beating technique. It's rather amusing reading, actually. So why today do we need bulldozers, heavy-duty appliances, water bombers when a red gum branch would do the job? I can only assume that most of the fires they fought 100 plus years ago were in young, light fuels, perhaps a legacy of Aboriginal burning by early settlers who grazed stock in the forest, and burning by timber millers. By the late 1940s and 1950s in southwest WA, cracks began to appear in the prevention and suppression policy with a spate of damaging bushfires. This culminated in the infamous and so-called Dwelling Up Fire in 1961 and subsequent Royal Commission. Would add, while it was called the Dwelling Up Fire, it was a lot more than that. Most of the southwest forest region was ablaze. The Royal Commission was a watershed for fire management in southwest. While prescribed burning was introduced in the 1950s, before the Dwelling Up fires, not much actually happened by way of on-ground action, largely because of a lack of capacity of the then Forest Department, lack of resources, lack of knowledge, and also I think a lack of commitment to the policy because, as I mentioned earlier, the foresters of the day were divergent in their views on the efficacy of prescribed burning. However, this changed after 1961, driven by the Royal Commission recommendations. There was a huge effort into applied bushfire science, both fire behaviour and fire ecology, specifically aimed to support a program of broad area prescribed burning to mitigate the bushfire menace. And most of that early research was done by the then Forest Department scientists in partnership with CSIRO scientists. So while planning and implementing a prescribed burn program is quite complex, the rationale for doing so is quite simple. Experience and bushfire behaviour science show that if fuels are allowed to accumulate over large areas, summer bushfires will be severe, damaging and difficult or impossible to control. In forest fuels, for example, the current fire behaviour model suggests that doubling the fuel load, or certainly the MacArthur model, doubling the fuel load results in a 4-fold increase in fire intensity because doubling the fuel load doubles the rate of spread. Reducing fuel load and flammability by regular prescribed burning reduces the speed and intensity of bushfires and therefore provides a wider opportunity for their safer suppression. After almost 60 years, organised and systematic prescribed burning has without question significantly reduced bushfire losses in the southwest forest regions of WA, and without ecosystem collapse or biodiversity loss, I should add. Today, across the country, there is less bushfire research done by fire and land management agencies, and more is being done by the universities, by CSIRO and by the CRC. There are fewer bushfire scientists in state land management agencies, but I'm pleased to say that at least here in WA, we've managed to, I guess, against the odds to some extent, to maintain an in-house bushfire research capability, and we've managed to maintain that since the 1960s. And I think there are some really important benefits of having scientists embedded in fire and land management agencies. Apart from generating or otherwise acquiring the science necessary to underpin agency policies, scientists in or working in close partnership with land management agencies, and I give an example of the close working relationship that we here in WA have had with CSIRO for many decades. Scientists working in this environment understand the bigger picture of community expectations and of fire and land management. They understand the challenges and they share the responsibility on agencies to protect our communities and our assets from destructive bushfires. They understand the complex operational aspects of prescribed burning and bushfire suppression. They participate in policy development, problem solving, fire management planning and fire operations, including prescribed burning and fire suppression. In short, they have skin in the game. They're also available for, and I know this only too well, responding to parliamentary questions and ministerials that fire management, especially prescribed burning, generates. And as I said at the conference in September, it's a part of the job I won't miss. When it comes to the benefits or otherwise of prescribed burning, there's clearly conflicting evidence, and there's no hiding that, and differing opinions, somewhat split along professional roles and responsibilities. Many scientists, and these are mostly from academia, where science is increasingly a theoretical enterprise, have published papers claiming that, variously worded, prescribed burning done at the spatial and temporal scales necessary to mitigate the bushfire threat threatens biodiversity. That prescribed burning is ineffective at mitigating the bushfire threat under severe fire weather conditions, when fuel load is unimportant. That prescribed burning is only beneficial when carried out within 100 metres or so of the urban fringe, and that prescribed burning can increase rather than decrease the fuel hazard. On the other hand, most fire practitioners and fire scientists embedded in or who work closely with fire and land management agencies are convinced that the scientific and experiential evidence supports the case that prescribed burning, and importantly done at appropriate scales, is very effective at mitigating the bushfire threat. In fact, it is critical to the cause and does not pose long-term threats to biodiversity. They, and I am one of them, claim that together with managing fuel on private property, around homes and at the urban fringe, broad area prescribed burning of the wider landscape is critical to mitigating the bushfire threat. Prescribed burning for bushfire mitigation is compatible with biodiversity conservation, and certainly, to my knowledge, there is no evidence that prescribed burning in forests has caused any loss of biodiversity. We know that old fuels are more hazardous than young fuels. Frequent burning reduces landscape flammability and breaks or buffers the bushfire cycle. Fuel age and fuel load affects, as I mentioned earlier, affects fire speed and fire intensity, so will strongly influence the success or otherwise of suppression actions and community preparedness, including under severe fire weather conditions. Opposition to broad area prescribed burning is summed up by this statement made to the local media here in WA by an academic following bushfires near Albany earlier this year, some of which unfortunately were escapes from prescribed burns. Once again, via this statement, it's claimed by academics who in this case have little or no fire management experience and who are not recognised as bushfire experts, that prescribed burning endangers biodiversity, is expensive but delivers no benefit, and that fuel management should focus on green belts around towns and other assets rather than prescribed burning. The pro-burners, if I can call them that, base their case largely on bushfire science, bushfire behaviour science, which demonstrates that reducing fuel load and simplifying fuel structures significantly reduces fire behaviour, thus making fires less damaging and easier to suppress, including under severe fire weather conditions. They also based their case on experience, occasionally published as case studies. Unfortunately, too few case studies have been published. Where from that experience, adequate prescribed burning has saved the day, and conversely, where inadequate prescribed burning has lost the day. Each year in the southwest WA, and it'd be the same across the country, I guess the southern part of the country, our firefighters are called out to hundreds of bushfires, and in most cases they're able to contain them relatively quickly because they're assisted by young fuels in the landscape as a result of prescribed burning. As I alluded to earlier, unfortunately, few of these case studies are actually published. They also based their case for prescribed burning on history in southwest WA. After almost 60 years of, we've got about 60 years of historical data for the forest region that shows a clear inverse relationship between the area of prescribed burning and the area burnt by wildfire. And generally, there's a relationship between the area burnt by wildfire and damage caused by wildfire. With respect to biodiversity, certainly studies in Western Australia and in other parts of the country have shown that fire, including prescribed burning, it certainly causes changes in species abundance and composition, but I've yet to see any evidence that prescribed burning has caused species losses or biodiversity loss in forest ecosystems. The anti-burners, if I can call them that, based their case largely on theory, modelling and computer simulations of prescribed burning scenarios and the subsequent bushfire mitigation outcomes. They based their case on a case study or two in southeastern Australia, but where the area that was prescribed burnt was less than 2% of the region per annum. This work doesn't prove prescribed burning is ineffective, as the authors claim. In fact, it is entirely consistent with the historical evidence and the experience that demonstrate that at least 8% per annum of a bushland region or a forest region needs to be burnt to be effective. We know that. They based their case on at least one space for time fire ecology study in shrublands, which showed that frequent fire caused the loss of some plant species. But when you examine this paper, you find that the landscape being studied had experienced a prescribed burn and several bushfires at frequencies greater than that what would be normally implemented under a managed prescribed burning program. They based their case on population viability modelling, theory and computer simulations, usually based on plant and animal life histories and vital attributes, such as the juvenile period of fire-sensitive, slow-maturing obligate cedars. So basically, if the fire interval is less than the juvenile period, then extinction is likely. As a bushfire scientist and a land management agency, I've spent many, many days in the field lighting, observing and studying experimental fires and their effects, and many days observing and studying prescribed burns and bushfires, and many days in large fire organisations and preformed incident management teams helping to put fires out, and many days trekking through blackened landscapes with a notebook, a compass, a clinometer, a GPS, attempting to reconstruct the origin, cause, behaviour and path of damaging bushfires. From these experiences, I am convinced beyond any doubt that the cornerstone to mitigating the bushfire threat, not preventing bushfires but lessening their impact, including in an era of changing climate, is prescribed burning. So I'm curious to examine more closely the case made against prescribed burning because it does not accord with my knowledge and my experience. But before I do, I want to put prescribed burning in perspective. Given the attention it receives, you could be forgiven if you thought that each fire season the country was ablaze with prescribed fires. Commentators have often referred to prescribed burning as, and I quote, a common and widespread practice. And recently it was referred to as, and I quote, an obsession by one academic. For temperate forests and woodlands of southern Australia, the truth is very little prescribed burning is done. Overall, about 1% per annum on average. And therein lies a problem. There is obviously variation between jurisdictions and within or with forest and woodland types, but to obtain a finer scale breakdown than what I've shown on the slide is a job for another day, if we get the data to do that. I now want to take a closer look at the most recurrent published claims against prescribed burning and the evidence to support these claims. The first claim is that in forests, prescribed fire intervals less than 4 years will result in local plant extinctions. Prescribed fire intervals greater than 4 years will not mitigate the wildfire threat. The suggestion here is that we need to burn at intervals less than 4 years for prescribed burning to be effective, but doing so will cause extinctions, so we have a conflict or an impasse. This sounds logical, but it's not, because it demonstrates a lack of understanding of the temporal and spatial design of effective prescribed burning programs. It is neither necessary, feasible, nor desirable to burn the entire forest on a 3 to 4 year rotation to substantially mitigate bushfire impact. Local government has a role in ensuring compliance with bushfire law regarding fuels on private land and with bushfire building codes, etc. Public land managers have an obligation to manage fuels on the lands they administer. And to this end, in the southwest, the aim is to burn about 8% of the forest region each year. So nominally, this means about a 12-year rotation for a 3,000 to 5,000 hectare fire management cell. Ample time for fire-sensitive plants in this environment to recover. Because of the patchy nature of prescribed burns, parts of the management cell often remain long unburnt. It also means that at any one time in our southwest forest landscapes, which amount to about 2.5 billion hectares, about 45 to 50% of the region is carrying less than 6-year-old fuels, and about a third is carrying less than 4-year-old fuels. The burning is spatially strategic, not random. 60 years of experience demonstrates that this has been very effective at reducing bushfire losses, primarily because it has significantly assisted suppression operations. And I'll expand on this later. In the southwest, fire-sensitive plants and animals mostly occur in the less flammable parts of the landscape, such as riparian zones, broad valley floors with discontinuous fuels, and on rocky outcrops. These habitats rarely burn under mild prescribed burn conditions, so often remain long unburnt. However, they are vulnerable to summer bushfires in the absence of regular burning in the surrounding, more flammable forest fuels. This slide shows the typical patchy nature of a 5,000 hectare low-intensity aerial prescribed burn in forests north of Walpole here in southwest WA. The blue patches are unburnt or areas burnt by very low-intensity fire due to flammability differentials in the landscape at the time of burning. Much of this unburnt country is habitat for so-called fire-sensitive species, plants and animals that require longer fire intervals. It's very difficult to obtain a patchy result like this in old fuels. So in the prescribed burn cycle, these areas burn about every second or third cycle, or about every 18 to 24 years or so, which is adequate time for organisms that require long intervals between fire. Rock outcrops are another case in point. They provide a refuge for a suite of fire-sensitive and fire-independent or organisms that don't require fire as part of their ecology. And rock outcrops provide these refuges because of the discontinuous fuel structure on the outcrops. And they can best function as fire refugia if the surrounding flammable, more fire-resilient forests are regularly burnt by low-intensity fire. On the other hand, they fail as fire refuges if the fuels in the surrounding landscape build up to high levels because the inevitable summer bushfire will be so intense that it will overwhelm the refuge characteristics of the outcrop, impacting everything on the rock. In exactly the same way, a 100-metre fuel buffer around the urban fringe will eventually fail if fuels are allowed to accumulate in the broader surrounding landscape. Some plants are killed by moderate to high-intensity fire but can survive low-intensity fire. And the relationship between Banksia woodlands, the endangered Carnaby's cockatoo, and fire is an interesting case study that one of my colleagues has been working on. Because these Banksias have a relatively long juvenile period, I think it's about 6 or 7 years, and because they can be killed by fire and rely on seed for regeneration, it was proposed that by some that prescribed burning intervals should be more than about 15 years to maintain seed supply for the cockatoos. This sounds logical on the surface. However, it treats all fire as lethal, so that if the Banksia woodlands burn, then the Banksias are killed, Certainly, intense summer bushfires damage and kill many trees over large areas, resulting in a long period of low seed supply while the plants regenerate and mature. However, frequent low-intensity fires are far less damaging and far less lethal to the trees. They actually survive these fires, or many of them survive the fires. And the severity of bushfires in these low-fuel situations is reduced, and there is far less disruption of seed flow to the cockatoos. So the notion of excluding fire for long periods to benefit seed flow to the cockatoos is actually the reverse of what needs to happen. Turning to the second claim, based on a number of published computer simulations, prescribed burning is not effective unless unrealistically large areas are treated very frequently. And based on computer simulations, it's also claimed that under extreme fire weather conditions, fuel load is not important because fires will exceed controllable intensities regardless of fuel load. This does not accord with the historical evidence, the experience of firefighters, and my experience. So what is the historical and real-world evidence? There's really only one jurisdiction in Australia that has been able to implement and maintain a prescribed burning program in forest landscapes at the temporal and spatial scales necessary to reduce the damaging effects of bushfires, and that's here in southwest WA. Some 60 years of experience has taught us that at least 8% of the region must be burnt each year, that the burn cells must be large, burns must remove a high proportion of the dead fuel, and the burns must be strategic. That is, they must be in the right place. It's often stated that prescribed burning is done to protect communities and other assets. Well, it's actually firefighters, community preparedness, building code compliance, police, legislation, etc. that protects communities. And by that I mean if all we did was prescribe burning and none of these other things, communities would still be at risk unless the bush was burned every 3 to 4 years. However, prescribed burning done at appropriate scales massively assists suppression operations and significantly synergises community preparedness and other risk mitigation measures. So through this, prescribed burning greatly enhances community protection. Computer simulations have a number of serious shortcomings and limitations in this regard. That is, they fail to adequately account for the benefits of prescribed burning to fire suppression and community preparedness, leading to erroneous and dangerous conclusions about the efficacy of prescribed burning. Simulators deal simplistically and inadequately with bushfire suppression. In simulations, if the maximum fire intensity in a small simulation cell exceeds 4,000 kilowatts per metre, then the fire is considered uncontrollable. The reality is different. The process of wildfire suppression and pre-suppression is much more complex and sophisticated. Simulations ignore the variety of suppression strategies and tactics that can be used in space and time, depending on weather conditions, fuels, topography, fire behaviour, fire shape, and fire position in the landscape, and fire intensity around the fire's perimeter. The head fire of most bushfires, certainly in my experience, exceeds 4,000 kilowatts, so firefighters rarely make a direct attack on the head fire. Instead, they implement other strategies, including a variety of direct and indirect attack or defensive strategies. So a fire is not considered uncontrollable or unmanageable because its intensity exceeds 4,000 kilowatts. Fire intensity varies around the fire's perimeter, and there will almost always be somewhere on the fire perimeter that can be attacked, either directly or indirectly, even under severe fire weather conditions. And if the fuel loads are low or the fuel ages are young, this opportunity widens and the likelihood of success increases. Most damage is done when the wind shifts and the long flank fire becomes a wide head fire. Therefore, containment work on the flank is critical and is more likely to succeed in low fuel conditions when the flank fire intensity is relatively low, even under severe fire weather conditions. Also, simulators don't take account of suppression advantages when part of the fire is burning with low intensity and light fuels, so it can be ignored while resources are diverted to higher priority areas around the perimeter or to other fires. Simulators ignore the anchor points or tie-in points, being the low fuel areas available to firefighters in a landscape that has been adequately prescribed burnt. These are very important for indirect suppression strategies, including backburning. Attempting to backburn in heavy old fuels up against heavy old fuels is a slow, resource-demanding, risky process, and the speed at which containment lines can be safely constructed is extremely important in the battle against a growing bushfire. Fire suppression is a race in terms of the rate of fire line construction and containment versus the rate of perimeter growth of the bushfire. Fires burn slower in younger, lighter fuels, not only improving the likelihood of rapid suppression, but increasing the odds of firefighters getting the upper hand in terms of constructing containment lines. With computer simulations, fires are only simulated to spread for relatively short periods of time, usually 6 to 12 hours, ignoring important diurnal variation in fire behaviour. Peak fire weather conditions don't last very long usually in the life cycle of a bushfire. When diurnal conditions ease and if the fire is burning in light fuels, there's a greater window of opportunity for safer suppression than if it's burning in heavy fuels. Simulations do not account for the synergistic effects of prescribed burning on community preparedness and response. That is to say, the success of these measures, community preparedness and response to bushfires, will be enhanced if the bushfire is less severe or if it's travelling slower with lower intensity. Regardless of the fire weather conditions, to firefighters, fuel load does matter. It directly affects fire intensity around the fire's perimeter and the size of the suppression windows in space and time. Also, containment line breakouts such as hopovers and spot fires are much easier to control in light fuels than in heavy fuels. Fuel load burning behind the flame zone, which is much greater in older, heavier fuels, is critical for suppression difficulty because total heat output acts in a number of ways. Firstly, it is an input to convection, which increases wind speeds in the flame zone. It boosts spotting and boosts fire behaviour. It increases the likelihood of high energy release rates and deep flaming conditions that can trigger a transition to a plume-driven fire and the development of dangerous pyro-CB events. It increases the likelihood of reignition of unburnt fuel and breaching of the containment line by burning embers, by blown embers or by hopovers. Radiation from glowing combustion behind the flaming zone adds to the heat load on firefighters and substantially increases the time before the burnt ground can be used for safe refuge. It substantially decreases the effectiveness of water and other suppressants supplied from the ground or from the air. Heavy fuels also hinder fire line construction and in some fuels make it impractical. Ignition patterns assumed in computer simulations are highly artificial, often a grid ignition at relatively close spacing. Similarly, the fuel management scales used in simulations are unrealistic. In reality, fuel is managed at much larger scales, or certainly in southwest WA. Simulations apply an unrealistic spatial arrangement of fuel management. The truth is, it is not random. Professional fire managers carefully consider many factors when planning the spatial design of a prescribed burning program, including assets at risk, cross-graining the prevailing wind directions that generate the worst fire weather, ignition risk, detection and suppression capability, burn scales that are commensurate with the landscape and with historical bushfires, the need to break the continuity of old heavy fuels, and how best to utilise and leverage previous prescribed burns and bushfires. Another benefit of landscape prescribed burning is that lightning strikes and other ignitions in fuels that are less than 4 years old usually do not take hold and become fires. This is important because there is a significant increase in the incidence of summer lightning storms in the southwest over recent decades. It's also claimed that in alpine landscapes, the least flammable parts are old growth, long unburnt ash forests, with the early post-fire stages being the most flammable. Therefore, it is concluded that fire should be excluded for long periods in these landscapes. Actually, this is not quite right, because following a severe fire in ash forests or any other vegetation type, the least flammable period is immediately after the fire. But that aside, this claim is based on a vegetation and fuel post-fire recovery trajectory following a severe, high-intensity bushfire that reduces the forest to black sticks and hits the reset button, as shown by the graphic. As the forest regenerates, it progresses through a stage of high fuel hazard rating due to the structure of the regeneration. I would add that not only is the forest hazardous at this stage, but if it's reproductively immature, it's also quite vulnerable to a fire. So what the author actually means is that the severe stand replacement bushfires in these landscapes increases their flammability for some time until they become old growth and creates a bushfire feedback loop, so that we need to ensure that bushfires are few and far between. certainly severe bushfires that create this trajectory of regeneration. And this can be, reducing the likelihood of this happening can be best achieved by regular low-intensity prescribed fire. A low-intensity fire, that's fire that removes a portion of the dead fuel without killing the overstory, does not cause such a dramatic restructuring of the forest. The forest essentially retains its old-growth structure, but its flammability will be reduced by a reduction in dead fuel load and a changing in structure of the dead fuel load, buffering the landscape against damaging stand replacement bushfires. In his discussion, the author of this particular paper noted in passing that low-intensity bushfire or low-intensity fires might not give rise to the flammability feedback scenario depicted on the slides, on the previous slide. To fire managers, this is a really important finding, but its significance was apparently lost on the author and on the reviewers. So the reality is the best way to reduce the likelihood of large, severe stand replacement fires in the landscape is to actually introduce more frequent low-intensity fires. It's been claimed that based on computer simulations, it's only necessary to reduce the fuel hazard in the immediate vicinity, 100 metres or so, of the urban fringe and around assets, and that burning beyond this is ineffective. It's what firefighters often refer to as the ring of confidence. The reality is this. A system of 5-chain buffers or green belts was tried in the southwest of WA early last century and failed under severe fire weather conditions. Granted, today we have better equipment, better suppression systems, but what hasn't changed is the fuel. It still accumulates and it still burns as hot as it did 100 years ago. Unless the buffers are at least 1,000 metres wide, a large, well-developed fire, perhaps a plume-driven fire burning in heavy, long unburnt forest fuels under severe fire weather conditions, will send fireballs, hot gas, smoke and a blizzard of embers across the narrow buffers, besieging the urban areas. If the bushfire approaching the buffer is moderate to low intensity as a result of low fuel loads and or low fire danger rating, the buffer might hold up. Secondly, this strategy of buffering, putting buffers around the urban interface places everything outside the urban fringe and the urban buffers at great risk. So beyond settlements, towns and subdivisions, and beyond these buffers that some people are advocating, they're talking about critical infrastructure of state-level significance and with no redundancy. Infrastructure such as major transport corridors, infrastructure associated with power and energy generation and distribution, water supply catchments, pipelines and pumping stations, major telco cables and towers, major waste treatment sites, and so on. We're also talking about locations where bushfires may have a significant impact on the livelihood of individuals or community economic sustainability, such as structures of local or regional significance, agricultural land, major industries such as mines, refineries, manufacturing plants, and native and plantation timber industries. Other significant built, natural or cultural assets, such as areas of transient population density and low resilience to bushfire, including holiday homes, hobby farms and recreation and camping sites, fire-vulnerable Aboriginal or European heritage sites, significant ecological community or species habitats, and natural areas with specific fire regime requirements become highly vulnerable. Firefighters will be expected to fight fires beyond the peri-urban buffers. Fires burning in long unburnt heavy fuels will be dangerous and difficult to control even under moderate fire weather conditions and impossible to control under more severe fire weather conditions. Given that there are thousands of kilometres of convoluted interface, how feasible is it to install and maintain a system of 100 metre or so fuel-reduced buffers to a standard that they will stop a running fire? The reality is we actually need to do both, manage fuels as best we can in and around settlements and around homes and at the peri-urban interface and in the broader landscape. While modelling and computer simulations testing the efficacy of prescribed burning are technically sophisticated and can provide some insights, they do not represent the complexities of the real world of fire behaviour and fire management. So the conclusions can't be trusted. Fundamentally, Their unreliability is due to a lack of understanding by the modellers of the complex nuances and variability of fire behaviour and how this influences fire ecology, field dynamics and fire suppression, and a lack of understanding of the complex art, craft and science of prescribed burning and suppression operations. Even if these complex aspects were well understood by modellers, it would be very challenging to incorporate them into computer models and simulators because much of this can't be distilled down to an algorithm. Yes, prescribed burning comes at a cost, and it is not without risk. But society and the environment will pay and have paid a much higher price as a consequence of bushfires in the absence of adequate prescribed burning. All good science starts with astute observations of the physical or natural world. Understanding bushfire and being a bushfire scientist means, as the name suggests, spending many days in the bush, observing, thinking about and interpreting fire and its nuances, and observing and interpreting the way species and ecosystems respond to fire. And I would argue that to be a good bushfire scientist requires many hours and many days in the field, lighting fires, helping to put fires out. I'm strongly of the view that science done without this prerequisite, without this sensory, physical and intellectual immersion in the world of real fire, is likely to lead to the wrong hypotheses being constructed and tested, flawed assumptions, unintentional bias, wrong inferences and interpretation of data, and erroneous conclusions. So to finish, to bushfire scientists, if there are any listening, I'd say this. In addition to the usual skills necessary to be a good scientist, you must also have a firm knowledge and understanding of fire behaviour, its variability and variable effects on ecosystems and on field dynamics. And you must have a firm understanding of the art, craft and science of prescribed burning and bushfire suppression. Consult with professional fire managers before commencing your research and before submitting your paper. You'll find that they'll be able to add significant value to your work because of their insights and experience. To science journal editors, I say this. Include professional fire managers in the peer review process. Most, if not all, are tertiary trained. Many have postgraduate qualifications, so they're well able to read and interpret and understand scientific documents. They are experienced in the real world of fire policy and management. They are very capable of and should be involved in reviewing scientific papers that could influence what they do and what impacts this will have on the broader community and the environment. And to land managers, I say this. Don't be intimidated by scientists or science. If it doesn't accord with your knowledge and your experience, question it. I think if we follow these through on these things, we'll get closer to the truth about prescribed burning. And that's all I've got. Thank you very much.
Thank you very much, Neil. I'm sure there's a solid round of applause coming from people's muted phones. With your permission, I'd like to open those muted phones up for questions, if that's okay.
Yeah, happy to go ahead with that.
Yep, just bear with me, everybody. I'll just unmute your phone.
The conference is now in conversation mode. All participants are now unmuted.
Okay, does anybody have any questions for Neil? I think they're just digesting all that fantastic information you gave them.
I can mute it.
Yeah, sorry, it's a bit rapid fire, but I'm conscious of time, so I sort of flogged through it a bit quickly, but hopefully the messages were picked up on.
Yep. I'll just pause for one more minute and make sure that no one has any questions they want to address to Neil.
Yep. And Deb, I'd certainly offer the invitation if people want to think about what I've said. They can certainly get back to me later on with an email or a phone call or something. We can have a chat about it that way as well.
Yes, and if you don't have direct contact to Neil, you can direct it through the Centre of Excellence and I'll pass it on to him. Okay, well, thanks for your time, everybody, and again, thank you very much, Neil, for coming out of your long service leave to present for us, and good luck with your forthcoming retirement.
No worries, and thanks again, Deb, for the opportunity.